Hi, everyone. Thank you for your patience. I had a few technical difficulties on my end, but hopefully you stuck around because I have a pretty exciting session planned, hopefully. My name is Anna Hoffman. I am a data and applied scientist slash program manager on the Azure SQL team at Microsoft. And today I'm going to be talking about Azure SQL, what to use when. And this is something you've probably heard about earlier this morning. If you listen to the keynotes, my colleagues Buck Woody and Bob Ward did one of the keynotes, and I believe Bob talked about SQL from edge all the way to cloud. So today we're going to focus on what those options are in the cloud and how you can go about seeing all these options not as a confusing thing, but more of as a benefit to really how we're able to kind of support you in whatever capacity that you need. Now, before we really get into it, I do want to call out that this event is done all for charity, so I encourage you to donate. When I heard about this event, the first thing I did was I went and donated. I told Bob about it and he donated, and then at Microsoft we do this matching program, so we're also able to get Microsoft to match our donations. So I definitely encourage you, if you've gotten anything out of this, these types of things usually cost a significant chunk of change to attend, so if anything you can donate, even if it's just $1, is going to make a difference towards our fundraiser. So thank you. And thank you for our sponsors who are kind of making this possible. And, it's a really interesting time for us to be able to do something like this. So I'm just excited to be a part of it. And I hope you all learn something in the process. So if we dive right into it today, we're going to talk about the various deployment options in Azure SQL that are available to be offered. We recently went through a little rebranding, so some of this might be new to you. And then I'll go into other choices you have around service tiers and purchasing models and a few other things. So let's go ahead and get started because we're a little behind. But that's okay. I think we should have time, and I'll also share all my contact info. So if you have questions, you can now use me as a resource. I'm always happy to help. So before we get into it, I thought it's always interesting to kind of take a step back and look at where we've come from. So if we look at the image you see on the left, this is from PDC 2008, or the Professional Developers Conference, kind of like Microsoft Build, but back then. Now, this is Ray Ozzie, the chief software architect at the time, and he got on stage in 2008 and announced Windows Azure. Now you know it as Microsoft Azure. But why I like this is he calls out, like from the very beginning of Azure, you see SQL Services is front and center. Now, I also found a blog post from around the same time, and I really like this because I think it kind of relates to this idea of what to use when. And this is from over 10 years ago, and it still pretty much applies today. You don't need to read the whole thing, but basically they say you don't need to provision hardware for, install, or patch it. You also don't need to architect it for scalability, high availability, or disaster recovery. And I think all of that still remains the main reason why you would move to Azure SQL and some of the huge benefits around availability, DR, and scalability. And we're going to talk about some of the architectures behind the scenes today that make that possible. Now, over the years, and this is kind of a lot of Microsoft sessions, so you're probably very familiar with this idea of Microsoft changing the name of things. So I always like to throw this up and show you the different name changes that not only Azure has gone through, but Azure SQL Database has gone from CloudDB to Azure SQL DB. And then if you look on the right side of the screen, we've just been adding a bunch of new capabilities in the past few years. And really, in 2020, what's not here is that we actually moved towards this idea of Azure SQL. And so we went through this rebranding exercise and said, okay, everything that falls into Azure from a SQL perspective, and when I say Azure SQL, I'm really talking about SQL Server, as a Azure service, type of service or offering. This is where Azure SQL comes in. So I wanted to start by talking about the overview of what's available in Azure SQL, or what we consider Azure SQL, and then we'll dive deep into each of those options. So if we look at Azure SQL, we're going to move from left to right, right? And as we go from left to right, what you're going to see is while you'll have more control, similar to Spider-Man, you'll also have more responsibilities. So if we start on the left, we start with infrastructure as a service. This is often referred to as IaaS, and what this is it basically means we're going to manage the infrastructure and the host, but you still have to manage the OS and you have to manage the SQL Server. Now, when we move to the right one level and we say, okay, let's abstract one layer away from you because you don't want to manage the OS, you just want a SQL Server. That's when we get into Azure SQL Managed Instance, which is one of our PaaS or Platform as a Service type of offerings. There's a lot of benefits towards moving towards PaaS, but one big one is this idea of versionless. So you never have to upgrade SQL Server or your OS ever again. Now, if we move one level higher to the right, at the furthest layer of abstraction, say, I don't want to manage the OS, I don't want to manage the SQL Server, I just want a database and I want to start building intelligent applications. And that's where Azure SQL Database came in. This was the first offering that we had of SQL in Azure. So this has been around for a long time, and there are lots of capabilities here from Hyperscale to serverless, which you'll learn about in this session. All right, so now you have an overview. Let's kind of dive into each of these options and why you would pick this one and what are some of the challenges and solutions. So we'll go through this framework for each of those deployment options. Now, the first is SQL Server and Azure Virtual Machine. Now, we see a lot of customers moving here because they want to migrate to the cloud, right? They want to start taking advantage of some of these capabilities around scale, DR, and availability. But they have some limitations that might make it difficult, not necessarily difficult, but there would be some effort involved in order to migrate to a platform as a service type of offering. With SQL Server and Azure Virtual Machine, you're basically able to get the exact SQL Server and OS version that you need, which is going to help you have a more seamless type of migration. Additionally, we know a lot of customers are leveraging potentially third-party software that needs access to the OS where the SQL Server is running. Now, SQL Server on Azure Virtual Machine is going to be the only deployment option that gives you that, because that's the only one where, like I said, you have access to both the SQL Server and the OS. So that's a big reason why we see people moving towards this service. Another thing is a lot of customers, believe it or not, even though we reached end of support over a year ago, I think for 2008, a lot of customers are still running on 2008. And what you can do if you move to SQL Server and Azure Virtual Machine is you can get free extended security updates for the next few years. So that gives you even more kind of runway to get ready to upgrade or migrate to a platform as a service. Now, one customer example that I really like is a customer called Allscripts. Now, Allscripts was able to move about 600 virtual machines using technology called Azure Site Recovery, and they were able to do this in about 2 weeks. So pretty fast migration, pretty smooth. And one of the cool things about them is after they migrated, they started to evaluate other services like Azure SQL Managed Instance. And ultimately, they started moving some workloads to Azure SQL Managed Instance. So I think Allscripts is a great example of taking a phased approach to migrating to Azure, where you kind of get your feet wet, you get your virtual machines, you get your same setup on-prem in Azure, and then you start looking at other ways you can take advantage of what the platform can offer. So that's SQL Server and Azure Virtual Machine. I'm not going to go into all of these details today. Myself and Bob Ward have been working on a lot of content for you all, so I'll share the GitHub repository with code samples and more, and some of the other things we're working on at the end. But I did want to call out one thing about SQL Server on Azure Virtual Machines. There's 2 ways you can deploy this. The first way, and this is very typical for most SQL Server professionals, is you would basically go deploy an Azure Virtual Machine, and then you would install SQL Server. You'd go download the right version and you'd install it. This is very typical. This is what everyone's pretty much been used to for years. However, if you go through this route, you're not exactly hooked up in the back end to the SQL Server on Azure Virtual Machines capabilities. So you're seeing some of those capabilities that are here, but in order to enable that on what we call a self-installed SQL Server virtual machine, you have to do this thing called resource provider. So you just basically have to install this little agent, and that's going to help us do things like advanced data security, which is previously only available in platform as a service offerings, but can be made available for IaaS like this if you have things like resource provider and a few other agents installed. So that's the one way. And then the other way, and I'll show this at the very end, is you can actually just go deploy a SQL Server on an Azure virtual machine where SQL Server is already installed. So that can save you a lot of time, and you can get the exact OS and SQL Server version that you want without having to actually go through the process of installing SQL Server. A lot of other stuff to look into, which I'll share resources on at the end. Now, we said as we move from left to right, you get more capabilities from Azure built in. And so when I say IaaS versus PaaS, we're talking about SQL Server and Azure Virtual Machine versus Azure SQL Database and Azure SQL Managed Instance. And a lot here, but basically for Azure SQL Server and Azure Virtual Machine, most of these things are possible. There's a few exceptions on the screen, but most of these things are possible. You're definitely going to get high availability. You're going to be able to set up automated backups and long-term backup retention or GeoReplication, but it's going to take a little bit more work, right, with IaaS. Where with PaaS, a lot of this is built in and with a few clicks in the portal or a few commands in PowerShell or the Azure CLI, you can actually set up, AutoFailover groups, which you'll see soon, or advanced data security is just kind of like a switch as opposed to having to install agents on a virtual machine. So that's really the key difference between IaaS and PaaS is just configurability versus being built in. And the other difference I talked about before is really this idea of versionless, which you get in database and managed instance, where you never have to worry about upgrading again. And one call out here too is that you can move with your current compatibility level. So you don't have to move to the latest DB compat to move to a PaaS service. So that's one thing that I think customers sometimes forget. All right, so now we're going to focus really for the rest of this session on all the different PaaS capabilities, starting with Azure SQL Managed Instance. Now, like I said, the first thing that we came up with was Azure SQL Database, and Azure SQL Managed Instance only came to be a few years ago. The reason for this is many customers wanted to move to this platform as a service. However, they needed access to things related to the server. So things I refer to as instance scoped features. So things like database mail, SQL Server agent, service broker, these are all instance scoped features, which you can only get today in Azure SQL Managed Instance. So this is going to allow a smoother migration for people who still want access to things in the server, at the server level. With this, you also get native virtual network support, and it is a fully managed service. So all the PaaS capabilities we talked about are going to be available here. Now, one customer I like to talk about when it comes to MI is Komatsu. Komatsu was able to migrate about a terabyte and a half worth of data to Azure SQL Managed Instance with basically no changes, and immediately they were able to see some pretty significant performance gains and cost reductions. You see there 49% cost reduction, which is huge, and 25 to 30% performance gain. So there's a lot of benefits to be had when you move towards a PaaS service like MI. Now, I mentioned this before, how things with PaaS, Platform as a Service, are oftentimes much easier than it could be certainly in on-prem, but also in IaaS. So one example of this is GeoReplication and AutoFailover groups. So if you think about the process before Azure of becoming a globally distributed application, this is something that took a lot of effort probably because you had to have lots of coordination and logistics in whatever region you were going to. And also you have to set all this up and communicate about it, and also be prepared if a failover needs to occur. Now I put up this table that kind of compares and contrasts the two differences between GeoReplication and AutoFailover groups. The reason I'm mentioning it here is AutoFailover groups is available in Azure SQL Database and Azure SQL Managed Instance, but GeoReplication is only available today in Azure SQL Database. Now, some of the big benefits of AutoFailover groups is if you need to do a failover automatically, this can help you with that, and also you won't have to change your connection string. So I thought the best way to kind of see this in action is to see it in action. So let's go ahead and we'll take a look at a demo. All right, a lot going on here. Let me just get this set up and then I will explain what's happening. So on the left side of my screen, what you're seeing is Azure Data Studio. Hopefully this is something you've seen before. If it's not, that's cool. This is a really awesome tool, not a replacement for SSMS, but kind of like a value add with some new things that you can do with it. One of those new things is a notebook. And another colleague on my team, Julie, she's doing a session, I think in about 5 hours, on Notebooks 101. So this is a really awesome session. If you're not familiar with notebooks, you've been hearing a lot of hype, I would definitely go check that out. Anyway, so what you're going to see is I've gone ahead and set up an AutoFailover group using a notebook. And a notebook allows me to basically mix code cells and text cells. So this is a text cell and this is a code cell. And the beauty is I can save the results and I have lots of different languages that I can use. So I went ahead and set this up because it takes some time, but what I want to show you is that it really only took 6 steps. So by step 7, I'm ready to kind of like use the failover group, create failovers, check the failover group status, that sort of thing. So 6 steps, so 6 commands in PowerShell, really less than that because some of those setups were like setting my variables and that sort of thing. But really like easy way to get failover groups up and running. Now, let's talk about what you're seeing on the right. So I have this failover group, and what basically a failover group allows me to do is just connect to the failover group as opposed to the actual database server or managed instance. And then in the back end, the AutoFailover group is going to take care of routing me to the primary or the secondary, depending on which one is in the primary role. So for example, if I run this, I'm basically saying get the failover group based on its name and get the role of my, what I called my DR or disaster recovery server, get the replication role. So right now my DR server is in the secondary position. So what that means is over here, I just have a very simple Java application, which is basically going to try to insert a row on the primary and then read that same row from the secondary. So this is just kind of to make sure and to check that we're able to connect to both and also that they're in sync. So what we're going to do, I'm going to scroll up so you guys can see it at the top of your screen, is I'm going to go ahead and kick off a failover, force an automatic failover. And I can do this, I can do this with the command switch, and then I just say which one I want to become the primary, which in this case is the DR server, and then the name of the failover group. So as this failover occurs, what you're going to see is my inserts and my reads are going to start to fail. Now this is expected, and this is one tip if I can leave you with is in Azure SQL, you want to make sure you have retry logic implemented because if anything little blip happens or you have a failover like this, you don't want to become down. You want to be up and running in your application as soon as the service is backend connected. So what you see is I tried 4 times to insert and read and I failed, but then I was able to resume my application as usual. Now I can run the same command from earlier that's basically getting the replication role of the DR server, and I can see that it's now in the primary. So I like to say, you know, this is just part of the power of PaaS and the power of the capabilities, how easy it is to kind of set this up and create a globally distributed application. Similarly, I could fail back. It's the same command, except now I'm saying promote the main server to the primary, and we'll kind of see the same result here where we'll fail a few times and then we'll be back up and running. And I'll share the code for all of this so you all can take a stab at it yourself. It's not super difficult to set up. I guess the biggest pain point is setting up Java on your machine or your virtual machine. All right, so we can see we're back connected to that. So I'm going to go ahead and hop back to my slides. So again, that was the power of PaaS. This is a capability available in MI and DB. All right, now the next thing I want to talk about, this is all the way to the right from our first screen. So we abstract away the OS and the server and say, I just want a database so I can build modern, intelligent applications. So there are a lot of capabilities in here, and we're going to spend some time kind of going through them. But I think the biggest thing is just flexibility. We have options for single databases or elastic pools. We have hyperscale storage if you need unlimited type of storage for your database. We have serverless compute we'll talk about. We also just introduced private link support when generally available, so you can get a fully private endpoint. The full DNS hierarchy is kind of obstructed from any public endpoints or hierarchies. You can get the highest availability with Azure SQL Database. You see over there 4 nines and a 5 for our SLA. And a customer I like related to Azure SQL DB is AccuWeather. And I like them because basically, they didn't want to have to worry about a server or updating versions or that sort of thing. They just wanted to build new intelligent applications, leveraging things like Azure Machine Learning Services and Azure Data Factory, and kind of build this integrated modern application to build predictive apps for their customers. Now, like we talked about in Azure SQL PaaS services, in Azure SQL Database, since we've abstracted away to the highest level, what that means is that the Azure platform has the most access to telemetry. And with that telemetry, we can do things like machine learning to help do things like automatic indexing. So there's a capability only available today in Azure SQL Database, and I wanted to show it off to you all. I'm going to switch back to my VM. I'm just going to quit that. And we're going to take a look at the Azure portal. So what I have here is I just have an Azure SQL database. And this is kind of the standard view in the Azure portal. Hopefully you've seen this before. If not, definitely go check out the database portal. But what I'm going to do is I'm going to scroll down on the left to this section called Intelligent Performance. Now, if I go to Performance Overview, I'm going to get right off the bat, and notice I didn't have to set anything up for this, right? I just get this by deploying a service, a performance dashboard. And there are a few things in here. I wanted to first look at this first one, so top 5 queries by CPU consumption. Now, with this, I can actually see the various stats related to different queries, and I could even, click into this and drill deeper and see more information about the query, as well as actually go into the exact query text and get any recommendations if there are any recommendations. So this is really cool that you have this drill down capability right from the beginning. The other thing that I have is I have some recommendations, and I have settings for automatic tuning, which we can take a look at. Now, what I'm looking at here, let me just make this a little easier to see, is I'm looking at the recommendation. So basically behind the scenes, Azure is looking at my telemetry, running machine learning models, and trying to figure out how can I make you run faster. So we can see it's ranked these by impact. So it says, if I create this index, we think it'll have a high impact on performance. It can also do parameterizing queries and dropping indexes. Now, if I just take a look at this one create index, I'm going to see some information about it, the index type, the schema, all the information I would need to know. I can then say, okay, let's go ahead and I'm going to select all of this and I'm going to copy it and I'm going to go implement it in my database. So that's one option that I have. The other option that I have is I can just click apply, and it basically says it'll start the process and then it will validate it after creation. So basically what this means is it's not going to actually implement the index immediately. It's going to look at my workload and pick a time where I'm not heavily utilizing resources. Then it'll apply the index, and then it will monitor to make sure it actually did improve the performance. And if it didn't, it will, undo the action that it did. Now, the other option I have here is to automatically apply create index in the future. And so if I'm managing a lot of databases, or I don't have the skills or the capacity to go through and look at all these and figure out which to apply, I just want Azure SQL to do it for me. That's what I can do here. So knowing that if it doesn't improve the performance, I'm going to see Azure SQL Database, undo whatever it did. So it's never going to hurt me, right? So I'm going to go ahead and click OK. And what we're going to see is not only did that index we first saw go into the pending state, but another create index did as well. And that's because, like I said, we set on the enable this to automatically apply and create indexes in the future. So really cool capabilities here. And again, this is going to say pending because we have not, we're going to wait until a time of low utilization, apply it, and then make sure it resulted in a positive impact on performance. So that's, oops. So that's automatic tuning. I hope that was something maybe new to you. If you're using Azure SQL Database today, remember you just get this so you can go access it today and kind of see what recommendations are there. It's not turned on by default for obvious reasons, but definitely go check it out if it's something you haven't seen before. It's really cool technology. In a way, you're kind of able to leverage, like I said earlier, the power of PaaS. All right, so we've talked about the deployment options, but I wanted to mention two more options related to pooling. So with Azure SQL Database, we have this thing called elastic pools, and that basically allows you to have many databases that share resources. And the reason you would want to do this is if you are, say, potentially like a software as a service application, and maybe you have a database for each customer. This also is going to allow you to resource share and cost optimize between databases, which is something you can't do today with a single database. And for Azure SQL Managed Instance, something a little bit newer, this is still in public preview, is an instance pool. Why would you want an instance pool? So if we take a step back and think about the deployment of Azure SQL Managed Instance, this tends to take some time. And also there's a minimum vCore requirement. So if you had a small instance you wanted to migrate, you might have to scale it up, making it more expensive than you like. However, what instance pool allows you to do is basically pre-provision a pool with the resources that you need, and then you can very quickly deploy managed instances inside of it, even with smaller vCore minimums. So for example, I think the smallest today is 2 vCores in an instance pool, which is smaller than what it is in a single instance. So this is going to help with cost-efficient and time-efficient migration because you can kind of pre-deploy the instance pool. So these are some of the pooling options, and now you've seen the deployment options, and so hopefully you're already starting to see like, wow, there's a lot of capabilities, a lot of options for me to get what I need, and maybe you're thinking of a project that you have that might make sense for one of these. The next thing you have to consider is, okay, how do I want to be billed for this? How do I want to pay for this? And how do I want to get my resources? And for Azure SQL Database, note this doesn't apply to Managed Instance, but for Azure SQL Database, you get to choose between the DTU model, which is an older model that's been around for longer. And what it is it basically, as you see, it scales linearly. So you just pick a level of DTU, and we're going to give you some amount of compute and storage. So this is going to give you the simplicity of choice. Whereas with the vCore model, people said, well, I kind of want to be able to pick my compute and storage and not have to scale, if I don't need a lot of compute, but I need a lot of storage. So with the vCore model, which is our newer, more modern, and honestly our recommended model, you're going to get more, you're going to be able to scale independently between compute and storage. With the vCore model, you're also going to get access to additional cost savings. Azure Hybrid Benefit, which is basically applying your existing licenses, as well as reserve capacity, are only available in the vCore model today. So that's one reason why I put that thing up there that says Microsoft's recommendation. Now again, this choice is only available if you're dealing with Azure SQL Database. For Azure SQL Managed Instance, since it came out since the vCore model was out, there is no DTU option. So you're just, you pick vCore by default for MI. Now, once you pick the purchasing model, there are various service tiers. We'll talk about general purpose, business critical, and hyperscale. I'm just going to use the architectures loosely just to kind of relate to how this relates to SQL Server on premises, if that's something you're familiar with. The first option is general purpose, and this is kind of our most cost-efficient offering. This is where we see most of our customers today, and so my recommendation would be to probably start here. But let's take a look at how this works. So it's going to behave sort of like a failover cluster instance, if you're familiar. Basically, on our primary replica, let me see if I can do this. On our primary replica, we're going to have TimTB running on directly attached SSD. But our data and log files are going to be stored in locally redundant storage. That's what LRS means. So there's multiple copies in Azure Premium Storage. So it's a little easier for us to get to than our backup files, which are stored in Azure Standard Storage. But those Azure Standard Storage are in globally replicated storage, which basically means just by deploying a database, it means even if your region goes down, something catastrophic happens, you have globally redundant storage, so you can do a geo restore without any configuration into another region in the case of an emergency. This comes with all tiers, and it's something, you know, that's really awesome in terms of disaster recovery. Now you might be wondering, okay, so if something happens and I need to fail over, what happens? Well, all of the Azure services run on the Azure backbone, which is Azure Service Fabric. And so if we detect that something is up and we need to fail you over, or you want to fail yourself over, basically it's like a failover cluster instance. We'll look for a node with spare capacity, and then we'll fail you back over and we'll repoint you and all that jazz. But you won't have to change your connection string. Again, you just need to make sure you have retry logic implemented in your application. So that's general purpose. Now, business critical, as the name suggests, is really meant more for those applications that really need low latency and the highest availability possible. And these are based on an always-on availability group. So if you're familiar with this concept, basically we are going to keep 3 secondary replicas automatically created. They'll be ready, and we'll actually let you use one of those secondary replicas as a read-only endpoint. So right off the bat, you deploy behind the scenes, you've got 3 secondary replicas and 1 that you can use for reading. Now similar, well, I guess a little different from general purpose is on each replica, it's not just your TimTB, but also your data and log files are running on locally attached, directly attached SSDs. And similar to general purpose, your backups are going to be stored in geo-replicated storage, which again is going to help you in the event of some catastrophic failure where a whole region goes down. And if a failover needs to occur, we're just going to simply repoint you to one of the secondaries, and you're basically up and running. And in the back end, we'll spin up another secondary. And you don't have to change your connection strings. Again, you just want to make sure that you have retry logic built in. Now, again, this is, in my opinion, part of the power of PaaS, this level of availability that you get without doing anything. No configuration, you just get an SLA and pretty high availability. And so I wanted to show off, you know, how fast some of these failovers can occur. So I'm going to switch back to my virtual machine and just bear with me because I got a lot of screens I'm going to pull up right now, and then I will explain them. Again, I'm going to be using Azure Data Studio. I'm a big fan of the PowerShell notebooks. So let's see if we can get this running. And then I will explain. Cool. All right. So what I have on top is Azure Data Studio, and on the bottom, I have 2 PowerShell windows open. Okay, so the left side of the screen, so just look at the left side of the screen for now. This is a general purpose database. So remember, this is like a failover cluster index. And what I'm going to do is I'm going to leverage OStress. OStress is a tool that Bob Ward showed me, and now I use it all the time just to create loads and also to show off the importance of retry logic. But basically what I'm doing here, I'll go ahead and kick it off. Maybe. There we go. What I'm doing here is I'm running this command, basically connecting to my database server, select count from a table, so just returning something. And again, this is on my general purpose database, and just do this 5,000 times, one thread. Again, this is a super easy tool to use. It's very cool. I'm a big fan. So we're just going to keep seeing those results here for my general purpose database. And this is also going to allow me to see, or you to see as well, if we're connected. Similarly, on the right side, everything over here is for a business critical database. So it's the same query, select count from a table, except this time it's connected to my BC database. So I'm going to go ahead and kick that off over here. So we see kind of the same thing going back. It'll just kind of flash upon our screen as they go. Now what we're going to do is we're going to force a failover. This is something you can actually do with PowerShell. It is limited. You can only do one failover every 30 minutes, but you are able to force a failover. So what we're going to do is we're going to force a failover on our business critical, force a failover on our general purpose, and see how long they take. So I'm going to try to do it at the same time. So immediately what you saw on really both, but more on the right side first, is that this business critical, before I can even explain it, this business critical database become unavailable for us to connect to. But because we're just doing a redirection to a secondary replica, which already exists, this failover took place in like just a few seconds, and it's always very exciting to me. I get pretty excited about it, but it's very cool how fast it was able to fail me over. Even the general purpose one was able to fail over less than 25 seconds. But what we saw is the reason it takes a little bit longer is because behind the scenes we have a failover cluster instance. So we're looking for a node with spare capacity, and we're failing us over there, moving the data over there. Whereas here in business critical, we just kind of have it already ready to go. Now both scenarios are pretty powerful because again, I did nothing to set this up, right? It's just what I get out of just from deploying, I get this capability and this power of TAS. So pretty powerful capabilities, I think. Hope this was interesting. Again, I'm going to share all these scripts and notebooks so you can try it for yourself. All right.
Hey Anna, sorry to interrupt you. We are having only 5 minutes left to complete the session. So
Okay.
I just let you know that.
Thanks.
5 to 10. Yeah.
Awesome. So we have about 5 minutes left. I'm just going to wrap up. What the final tier I wanted to share with you is the Hyperscale service tier. Now this is only available in Azure SQL Database today. And basically, I'm not going to get into it today. We have lots more sessions and content that I'll point you to at the end of this that really go through how this works. But it's a really amazing technology where we've basically re-architected SQL Server for the cloud. So we're able to scale out, and similar to Business Critical, you can get more replicas, more read replicas, but actually in Business Critical, you just get one, whereas in Hyperscale, you can get up to 4. So you can have 0, in which case your failover will be like general purpose because you don't have a secondary ready. But if you deploy 1 or more replicas, secondary replicas, then you're going to have the capability to fail over much faster. And a big part of this is that we took the log service out. Again, I won't get into these details, but we took the log service out, and that's going to enable a lot of this to run very quickly, and we were able to eliminate some of the size of data operations that are tied to having, 60 terabyte size database. So in summary, we talked about all these different service tiers, and this is just a slide that kind of compares how they perform. Now, when you see I/O per second there, that's what IOPS is. The plus and the plus plus just symbolizes which one is more IOPS or I/O per second. And a few other things that kind of differentiates these, like you get 1 readable secondary as part of your availability, always on availability group, versus you can get up to 4 readable secondaries in Hyperscale. And the one thing we didn't talk about yet is serverless. This is only available in the general purpose tier of Azure SQL Database, and this is really meant for workloads with intermittent or unpredictable usage. So For example, if I have a line of business application, like at a bank, and people only use that application during the day, what it's going to do is it's going to scale on a per second basis for the exact CPU and memory, the max of that I need. And then we're going to use an interesting cache reclamation process to kind of bring us back down. So you'll only build for what you use. And after a set of time where I'm inactive, so I can say, you know, after an hour, actually pause the database. And during this time, I don't pay for compute. We've separated it. SQL Server shut down. I only pay for storage. So this is another really interesting use case that we're seeing a lot of interest from customers. So I definitely recommend looking more into this, and we'll share some resources. The last choice is hardware. I won't spend a lot of time here due to time, but basically Gen 5 is your main option today, but you should know that in the future and as we go forward in time, we're always going to be coming out with more hardware. This isn't to make your life difficult. This is just to keep you on the latest and greatest hardware with more capabilities as they come out. Now, these are all the options that we talked about today. I'm going to share this deck with you all so you can kind of digest this. I know it's a lot that you've seen today, but hopefully you're feeling like you got a better view of what's possible with Azure SQL and how all these choices are really there to make your life easier, not more difficult. I know we're about at time, but one thing you could do if you just go to the Azure portal, we now have an Azure SQL Blade where you can see all your Azure SQL, whether they're a database or a virtual machine or a managed instance, they're all in one place. And we're even giving you a what to use when within the portal experience. Of course, this is taking a moment to load today. But basically, this is going to give you the same view that we've kind of been talking about the whole session today. So I definitely recommend checking this out. Of course, the portal's not behaving with me today. And with that, I will put up my resources. I definitely recommend checking all these resources out. If you didn't get a chance to see them after this, you can always find me on Twitter and I can send you any links that you might need. And again, please donate. This is for a great cause. Please donate in support of UNICEF, especially during these very challenging times with COVID and everything going on. And give us feedback. Let us know what you thought of the session. Again, we apologize for the technical difficulties, and also give us feedback on the event so we can make these sorts of events better as we go forward. And with that, I will stop and pass it back. Thank you all so much for your time, and I hope this was useful.